This video is again on section 5.1, homework assignment number 20. We're going to actually be working problems. We're going to be solving systems of equations, two variables, two equations using the elimination method. Some of you may have called this the addition method. I actually have in other books. If we have two equations, 3x plus y equals 5, 4x plus 5y equals 3, these are both linear equations. Now remember, these are going to either intersect in one point, no points, or all points. Now what we need to do in the elimination method or the addition method is first to decide which one of these variables we want to eliminate by adding. And I can see that since I have a 5 and a 1, I'm going to decide to eliminate the y. Now class, there's no bad choice here. You can't go wrong. But I'm going to eliminate the y. Now if I eliminate the y, what I want to do is to add 5y to something that will add to be 0. Well, this would need to be a negative 5y. So I'm going to multiply this entire first equation by negative 5. So that gives me negative 15x minus 5y, now all the way across, negative 25. I'm not going to change the second equation in this one. Sometimes I'll have to change both. Now remember, I said I wanted to eliminate y. If I add 5 to negative 5, that becomes 0. Now let's continue adding. Negative 15 to 4 is a negative 11x. Negative 25 and added to positive 3 is a negative 22. I need to solve. If I divide by negative 11, that would be x equals 2. Now, because I'm getting a value for x, I see that this is going to be a system that intersects in one point. I now need to find the y. So I'm going to substitute to get the second variable. You can go back into either one of these you want to. I think I'm going to take the first one, and that'll be 3x plus y equals 5. Now that x now becomes a 2, so 3 times 2 plus y equals 5. 6 plus y equals 5, or y equals 5 minus 6. Y would equal negative 1. Now that negative 1 is my y. Now think, I've got one point. In other words, those lines actually cross in one point. Now because I have one solution, they are consistent. And because they have one solution, they are independent. And really that's because they are not infinitely, if you remember, they're not crossing in all points. They're only crossing in one point. Okay? Now, let's look at example number 2. We have 3x plus 4y equals 2, 2x plus 5y equals negative 1. Now, I can choose to eliminate either x or y. That's going to be your choice. Now, in this one, I'm going to choose to eliminate x. Now, in a case like this, if you don't have a 1 as a coefficient, what I would always do is to multiply each equation by the other variable. In other words, 3x I would multiply by 2, and 2x I would multiply by 3. One of these needs to be a negative. It doesn't matter which. Now let's try this. That's going to be negative 6x, negative 8y equals negative 4. And then 6x plus 15y equals negative 3. Now remember, I'm trying to eliminate x. 6 minus 6 is 0. 15 minus 8 is 7y. Negative 4, negative 3 is negative 7. So that's y equals negative 1. Now, you notice again that I now have one part of an ordered pair. I have the y. So to get the x, I'm going to substitute. Go into either one of the equations you want to. I'm just going to take the first one. 3x plus 4 times y, that would be negative 1, equals 2. 3x minus 4 equals 2. Or 3x equals 2 plus 4. 3x equals 6. Or x will equal 2. Now again, I have two lines here that are intersecting in one point. Because they do intersect, they are consistent. And because they don't intersect in many, many infinite points, they are said to be independent. Now, all of our problems will not ask you for that information, but some of them will. All right, we're going to look at problem number 3. Now, when you see a fraction, the first thing I want to do is to get rid of the fraction. So here, there are two things I really need to do. I need to get rid of the fractions, and you notice these are written out of order. I need x, then y, then equals, then number. So I think I'll just go ahead and multiply first. I'll reorder them. That'll be 1/5 x minus 1/2 y equals 1/10. And now I want to move the x over. 3x plus 5y equals 14. Now I've got x, y, number, x, y, number. Now, I need to get rid of the fractions. I have a 5, a 2, and a 10, so my common denominator would be 10. I'm going to multiply across by 10. 5 divides into 10 2 times. 2 into 10 is 5 times. 10 into 10 is 1 time. Now let's multiply. That will be 2x minus 5y equals 1, and bring over 3x plus 5y equals 14. Now, I need to get rid of one variable, and if you look at this, it's just really sitting there, what we need to get rid of, and that would be the y, because 5y minus 5y eliminates itself. So I have 5x equals 15, or x equals 3. Now, that is my x value. I need to solve for y. I can tell you right now that because I'm going to get one solution, this is going to be consistent, and because I do have one solution, it's going to be independent. Now, what I need to do right now is to substitute either one of the equations. Of course, I'm going to go back to this second one. 5y equals negative 3 times x plus 14. So that'll be 5y equals negative 9 plus 14. 5y equals 5, or y equals 1. And my solution would be 3, 1. I think we'll stop this video and continue on another one.